Welcome to Radical Expressions. Today we're going to look at being able to multiply, add, and subtract radicals. Please take a second to record this information. We're going to start by looking at multiplying radicals. To multiply radicals, we have one pretty big important rule, and that is that the radicals have to be the same type of radicals. So the index value have to be the same value in order to multiply two radicals or more together. The overall process is as follows. Step 1, simplify radicals if possible. 2, multiply coefficients, which are your outside values. Multiply your radicands, which are your inside values. And then most often we have to definitely do another simplifying after the multiplication has happened. So we have the SRF step again at the end of the entire process. Here's our first example. Notice both of these radicals are square root radicals, which remember for square roots we don't really see the index because it's really the smallest type of root that exists. It's a common root. So here we both have a square root times a square root. So the first thing is, can you simplify each of these individually? And the answer is no. Then we are at step 2, which is identify your coefficients and multiply those, your outside values, which is understood in this case to be 1. So 1 times 1 is still 1. And then you multiply your insides. And so here we are getting 1 times the square root of 15. And then now that we've multiplied the radicands, we simplify the radicand, square root of 15 if possible. Square root of 15 is not a perfect square. It does not have any square values that can divide out of it, such as 4 or 9. And so in this example, this problem is done. Second example, we have 2 cube root of 3 times 7 cube root of 9. Again, you're going to want to begin by, can you simplify the radicals, cube root of 3 and cube root of 9, before we actually multiply and make things bigger? The answer is no. Usually you can tell you can simplify if the radicands are really big. Here the radicands are small. So the next question to answer is, can you multiply these radicals? And the answer is yes, because they're both cube roots, or these indices here match up together. So then you follow the process. The outside values multiply, 2 times 7. And then you have the cube root, and you multiply your radicands, 3 times 9, which is 27. Now we're at the last step, which is simplify the radical if you can. So then the cube root of 27 gets simplified to 3, since 27 is a perfect cube value for 3 times 3 times 3. And that gets multiplied to the coefficient that's already there. And so you end up with 14 times 3, which is 42. And that's the answer. Example 3, we've got 3 times 2 square root of 24. We begin by simplifying the radical if possible, square root of 24. It does have a perfect square, which is 4. So this will break down into the square root of 4 times the square root of 6. The square root of 4 is 2. And then 2 gets multiplied by this other coefficient that was there originally. And if you want, at the same time, it's going to get multiplied to the other multiplier that was there at the beginning. So now you've got 3 times 2 times 2, which is 6 times 2, so 12 square root of 6. Next example, square root of 32 times 5, square root of 27. Again, we'll try to simplify our radicals here. So in 32, we've got the perfect square, 16, 2 times. This will become 4 square root of 2. 27 has a perfect square of 9. 3 times. Square root of 9 is 3, so we have 3 square root of 3. We also have the 5 here, originally, that's there. So this is basically 15 times the square root of 3, and that is getting multiplied to this 4 square root of 2 here. And then now we can multiply our outside values. 4 times 15 is 60. Square root of 2 times 3 is square root of 6. And then now we ask ourselves, can we simplify the square root of 6? 6 is not a perfect square. 4 does not go into 6. And so we're done. Okay, switching gears now to adding and subtracting radicals. The key is remembering that every time we're adding and subtracting, it's got to be like terms that are adding and subtracting. So to determine if radicals are alike, there are really two things you're looking at. The index value, or the kind of root, has to be the same. The radicand, which is the value underneath, also has to be identical. So here is a pair of radicals that are alike because they're both fourth roots and they both have a radicand of 3. In this list, these radicals are not alike, so you could not add them. This one's a square root, whereas this one's a cube root, so the index don't match. And then here we have the index matching, but the radicands are different. So though that pair is not alike. Please jot down these notes. The overall process for adding and subtracting, step number 1 is to simplify your radicals first, so SRF each radical if possible. Step 2, identify which radicals are alike, and then so in step 3 you're actually going to add the like radicals, or add and subtract. The outside values are what does the adding, the coefficients. The radicands will not change. So here is a pretty classic example of adding and subtracting radicals. First step will be to simplify each of these radicals. And as soon as you're getting two-digit values, you know that probably you could do some simplifying. So you're going to have to SRF each of these, which will change each of these terms altogether. Then identify which ones are alike to add and subtract. So I'm going to need some space here. Square root of 12 has a perfect square of 4 3 times. And of course I'm going to bring down the 2 there. That's already in front here. This guy right there. The square root of 4 is 2. And we still have that other multiplier in front of that radical, and so this term will become 4 radical 3. That was all just to simplify this. The next term, we've got 27 broken down into square root of 9, square root of 3, square root of 9 is 3. And of course you notice me, I'm still bringing down that multiplier. And then we can multiply these outsides here. -9 radical 3. And so now the second term has been simplified. Notice this is all still simplifying. Square root of 48 has a square of 16 3 times. And it had the coefficient of 2 there in the front. Square root of 16 is 4. And then multiply your outsides here. You've got 8 radical 3. And then finally, now that you're simplified, which was all still the first step, you play the matching game. Which radicals are the same? Square root of 3, square root of 3, square root of 3. So these are all alike. And so in step 3, or the next step, is to actually do the adding and subtracting. So you're computing 4 minus 9 plus 8. So we have negative 5 plus 8. You're going to have 3 as your coefficient or outside value. Square root of 3 does not change. Okay, so again, all that we did was we combined the coefficients or add the outsides. 4 minus 9 plus 8. And we got 3 square root of 3. Here's another example that really puts the multiplication and the adding together. It's two binomials with being multiplied together. So this becomes a FOIL problem. First times first, outer times outer, inner times inner, last times last. Okay, so I'm going to show all my work here a little bit for this problem so that you have a structure of what's going on. You have 3 square root of 5 times 2. And then you have, for your outsides, 3 square root of 5 times square root of 3. And both are positive. So you'll get a positive there after you multiply. Inner, got a negative 2 radical 3 times 2. And then your last times last is the negative 2 radical 3 times radical 3. Okay, so I'm just indicating there what values are multiplying together. Now the actual multiplying I'll do in the next step. Back here, I've got outside value times outside value is 6 square root of 5 plus, here I have 2 radicals. They're both square roots, so they can multiply. So I multiply the inside, since this is a coefficient of 1 here, it's not going to change the 3. So I'll have square root of 15. Next term, I've got an outsider 2 here. It's going to multiply to this outsider. Minus 4 radical 3. And then down here, I've got, again, a 1 radical 3 here, so it's not going to change the negative 2, but I'll have square root of 9 when I multiply these radicands. So remember, multiplying will change your radicands. Now we simplify radicals. After you multiply, you always have to simplify radicals. 5 is already small. 15 does not have a square number in it. 3 is already small, but square root of 9 is 3. And that's multiplying to the minus 2. So this really becomes minus 6 here. I'm just going to bring down my work. Okay, so that was doing an SRF step here for each term. And then at this point you recognize which ones are alike that can be added together. Square root of 5 does not have a match. Square root of 15 does not have a match. Square root of 3 does not have a match. So there are no like terms to add and subtract. That means we're done.